Hi, Algebra 2 students, and welcome to video number 2 from Unit 7 review videos. And in this video, we're going to look at writing quadratic functions from given information, both looking at the information that we're given, picking an appropriate form, and making sure that we have a function that meets the conditions that were listed. Okay, this is a pretty quick video, but we're going to look at 3 examples here, starting with example 1. So, first piece of information they tell us is the vertex is a maximum. So what we want to be thinking with that is that this must be a parabola that opens down, because the vertex then would be at the top. It would be the maximum value that the parabola reaches. And so the way that ties into any of our forms, no matter what form we use, is that we need to have a lead coefficient that's negative. That's the only way that that parabola will reflect and open downward. So that's one thing. And then a second thing here that we have to consider is that the parabola is wider than y equals x squared. So if we picture y equals x squared and we graph something that's wider than it, notice now wider is not the way we described transformations, but the way this ties back to what we learned in first semester is it would be a vertical shrink, because notice at a given x value, the output would be a little bit smaller if that parabola was going to widen out. And so parabola being wider is the same thing for us as a vertical shrink. And a vertical shrink we know happens if the value of a's absolute value is less than 1. So we need to pick something where the absolute value of a is less than 1. It will have to be something negative, though, because of the first part where the vertex is a maximum. I think we can get away real easy here with putting something in standard form, and we really only have to address that first part of standard form, because as long as we pick the right a value, I think both of those conditions will be met, and we don't need to overcomplicate this. So I'm going to pick a value for a that's less than 1, but negative as far as its absolute value goes. So it's going to be y equals negative 1/2. X squared would work. Okay, negative 1/2 is certainly smaller than 1, its absolute value is, and it's certainly something negative. Okay, all right, example 2. This time, different information. We've got x-intercepts that are both negative. Okay, both negative. Well, if we're dealing with x-intercepts, I'm going to go to the factored form here, and I'm going to go ahead and start this out. I'm going to go ahead and write something in factored form with 2 negative x-intercepts. So maybe an x-intercept at 2, and maybe an x-intercept at -2, sorry, and maybe -5. And that will be that piece there. Now, the second piece of information is that the y-intercept must be 0, 8. And so what that means is if I fill in 0 for my x's, I better end up with 8 coming out for y. And what will happen if I fill those zeros in and that 8 in is I'll be able to solve for a in that case. So if I do that, and this is often what we do when we're writing from a graph or table, and those are in videos 3 and 4, I'll get 8 equals a. I like to do the math, so 2 and 5, and so it looks like if I solve that, it will be 8/10 or 4/5. And so now if I put this all together back with the original factored form, but with the now known a value, I'll have y equals 4/5 of x plus 2 times x plus 5. And that will meet both of those conditions that were given. Okay, one more example here, example 3. So we've seen one in standard form, we've seen one in factored form. So you might kind of predict here what's coming next. And sure enough, we see the word vertex here. So the vertex is in the second quadrant. Okay, well, second quadrant, remember, quadrants are numbered this way. Now you'll learn more why they're numbered this way in next year in pre-calculus when you study trigonometry. But if we're dealing with the second quadrant, we need a vertex over here. So I am going to pick, it has to be something with a negative x coordinate and a positive y coordinate. So -2, 5. I don't know why I chose that, I just did. And so if I take that and put that into the vertex form, that will give me y equals a times x plus 2 squared plus 5. Okay, all right, and my goal now is I still have to find out what that a, but that's why they gave me the other piece of information. So the x-intercept is at 5, 0. Normally we would think, well, that could be written as a factor. A factored form is x minus 5. But here, what we're going to do is we're going to use that in order to solve for a. Remember, we can solve for a by filling in any point that would be on the graph of the quadratic function. So if y is 0 and x is 5, I can set this up and solve to determine what a needs to be. So it looks like it would be 0 equals a times 7 squared plus 5. Negative 5 is 49a, and because of the vertex I chose, it turns out that a is kind of this funny looking number, but it's the one that works based on the vertex that I chose for the first part of this. So a is negative 5 over 49, and so my final answer, y equals negative 5 over 49 times x plus 2 squared plus 5. So we saw an example where we ended up in each of our three forms, each time a different form, but always take a moment to process the information, start in the most appropriate form, and then usually you have to do a little bit more work maybe to solve for another piece. In the end, we could have different answers here, but just make sure that whatever answer you end up with meets the conditions that were given. Okay, so I hope this video was helpful, and be sure to check out other videos if you're able to do so.